Extensive characterization of materials. Properties are commonly defined as extensive or intensive depending on the magnitude it is describing. To extensively characterize a material is crucial, since we find out the properties of the specimen, which is one of the main objectives of material science. Mechanical tests allow us to determine through different procedures the inherent and specific properties of a specimen. In engineering, this will later help us to choose the right material pieces to manufacture the product for whatever application we look for. The piece I analyzed was a 1018 steel test tube and a 1018 Sharpie steel piece. Material was tested in the same order I'm about to describe. The original length of the test tube was 2.98 inches. The original diameter of the cross-section was 0.503 inches. Therefore, the original area was 0.19 inches. The strain obtained from the test was 0.23. The yield strength was 62,671.1 psi. The tensile strength was 82,100 psi. The percentage of elongation was determined to be 23%. Area of reduction was calculated to be 0.64. Thus, the elasticity modulus was 668,492.2 psi. According to the data from book tables, we find that both yield strength and tensile strength vary a little from the results I obtained, being the error of only 16% in yield strength. The broken test tube was then mounted in bakelite, so I could handle it in an easier way. Once I did this, I started to perform Vickers hardness test. The results from manual Vickers test were diameter number 1, 52, diameter number 2, 51. Then the average was 51.5. The hardness was determined to be 215. Measurement 2, diameter number 1, 53.5. Diameter number 2, 53. Average, 53.25. Then the hardness was determined to be 217. The practical hardness was 131. In automatic Vickers test, the results were hardness number 1, 187. Hardness number 2, 191. As we could see, the results were not really close to what we can see in tables. Totally polished and treated with metal, it was ready for the metallographic analysis. I counted 31 grains at a 500 magnification. This means the grain size is 8 ASTM. As we know, the greater the number, the smaller the grain size. My specimen had small grains, which gives good mechanical properties to the material. Once I was done with the bakelite covered piece, I started working with the Sharpie piece. From this test, I obtained the next results. At 23 Celsius, the 1018 steel piece with 2.24 inches in length, 0.37 inches in width, and 0.37 inches in thickness absorbed a total of 52.5 foot-pounds, showing a ductile fracture. I performed Brinell test to the broken Sharpie piece with a force of 3,000 kilograms. Results were the next. Measurement diameter average number 1 was 3.15. The result of practical hardness was 363 and 388. The average was 375.5. The result of theoretical hardness average was 375.44. This means that their results are very alike. Finally, Rockwell test with a load of 150 kilograms gave the results of practical hardness number 1, 11, practical hardness number 2, 13. As we saw, many of the data obtained differs from the table due to several reasons. The most common are misunderstanding of the data obtained, parallax error, and even inaccurate measurements. The machine I liked the most was the automatic Vickers, since I was able to see any scratch on the polished surface. During the laboratory sessions, I learned how to use all of the materials and machines found there. I developed a lot of patience, especially when mounting materials like bakelite and waiting for my friends to do so too, so we could sand our pieces together. I think that this course was one of the most interesting courses I've ever had, and the laboratory made it possible to watch with my own eyes what I learned in the classroom. Also, I consider the final project one of the best projects I've ever had. I could apply all the competences I've learned. I failed a lot of times, yes, but I tried even more times to success. And all that time I dedicated to this course was useful. Something I like about the laboratory is the variety of machines that I can find. What I don't like about the laboratory is the sketch.